You spend thousands designing a gorgeous covered lanai, imagining cool summer evenings by the pool. But by 3 in the afternoon, the Florida sun turns that expensive patio into a completely unusable oven. A solid aluminum roof does a great job keeping the rain off your head, but it offers zero protection from the low-angle sunlight pouring in from the sides. And the standard bug screen wrapped around the frame? It does nothing to stop the heat. This means half of the year, one of the most valuable features of your property is effectively off-limits. You're paying a premium for square footage you physically cannot occupy without sweating through your clothes. There is a precise engineered solution to this. You can drop the temperature of your lanai by up to 15 degrees. But doing it safely means navigating some intense structural physics that most contractors never mention. The culprit is mean radiant temperature. Solar radiation strikes the concrete foundation. Concrete acts as a massive thermal heat sink, absorbing energy and re-radiating it upward. Because standard fiberglass mesh has a 30 to 40% openness factor, wide gaps let energy through uninterrupted. From a thermodynamic perspective, standard insect screening is practically invisible to incoming solar energy. It stops mosquitoes, but it lets the heat walk right through the front door. Unless you intercept the sun before it strikes the concrete, your lanai is doomed to act as a trapped microclimate. The trapped heated air will sit there, making the space significantly hotter than the grass in your backyard. The instinct is often to install interior shades, but once sunlight passes through the outer threshold, the heat is already inside. To actually cool the space, you have to stop shortwave radiation on the exterior plane before it crosses the boundary of the structure. According to data from the Department of Energy, exterior shading interventions can reduce solar heat gain by up to 65% on south-facing exposures and an incredible 77% on west-facing exposures. The physical solution is upgrading to a specialized exterior screen. Manufacturers weave heavy-duty vinyl-coated polyester or thermoplastic elastomers, dropping the mesh's openness factor from 30% down to a tight 1 to 5%. By managing that incoming energy entirely on the outside of the building envelope, we manipulate the thermodynamic equilibrium of the space. We keep the concrete in the shade. When people order these tight screens, they often assume a white mesh is best for cooling. But white screens have high visible transmittance. They scatter the incoming photons, which completely washes out your view and creates a blinding optical glare. The counterintuitive truth is that a dark mesh performs significantly better. A black screen acts as a giant solar heat sink. It absorbs thermal energy and safely dissipates it into the ambient outdoor air using natural convective microcurrents, long before that heat enters your lanai. Looking at this technical specification sheet for the solar heat gain coefficient, the 5% openness black-on-black nanomesh absorbs a massive 90% of solar energy, letting a mere 3% of visible light transmit through. The result is a patio that is 10 to 15 degrees cooler. You lower your home's overall cooling energy demand by up to 20%, and you block the UV rays that quietly destroy your expensive patio furniture. You might sacrifice a microscopic fraction of thermal efficiency by choosing black over white, but you eliminate the severe glare and preserve a crystal-clear, high-definition view of your backyard. But dropping a screen's openness factor from 30% down to 5% creates a massive hidden danger. You are taking a porous, breathable bug screen and structurally transforming it into a solid aerodynamic wall. Looking at these wind load pressure diagrams from the ASCE 722 codes, we see the external forces in play. When you increase mesh density, the code triggers punitive, fully enclosed building wind pressures. The structure must suddenly resist immense external stagnation forces and internal pressure buildups. If a contractor simply slaps a dense 5% solar mesh onto a standard unreinforced aluminum pool cage, the result will be catastrophic structural failure the moment a hurricane makes landfall. The frame simply cannot handle the aerodynamic drag. There is a specific regulatory workaround for this in Section 2002.7 of the Florida Building Code. If you install motorized retractable screens, structural engineers are legally allowed to use standard, significantly lower wind load calculations. The catch is that you, the homeowner, must legally commit to retracting the screens into their housing anytime wind speeds are forecasted to exceed 75 miles per hour. You cannot safely solve the thermodynamic problem of a hot Florida lanai without explicitly engineering a solution for the aerodynamic threat that heavy mesh creates. Surviving coastal weather requires severe mechanical integrity. If a builder uses cheap steel screws to anchor an aluminum frame in Florida's salty, humid air, galvanic corrosion will eat the joints alive. Using Type 316 stainless steel fasteners is absolutely non-negotiable. This diagram shows the critical concrete inspection points along the base of an enclosure, marked in safety orange to highlight the subterranean physics of aerodynamic uplift. Older, unpermitted paver decks fail inspections automatically because resisting extreme wind requires deep, continuous concrete ribbon footings. Navigating these strict engineering requirements is exactly why Screen Factory Florida exists. With a 4.8 Google rating and strict BBB accreditation, they build enclosures engineered to withstand the worst of Florida's weather, with a proven track record of durability during storms like Hurricane Milton. The right high-performance screen, rigorously engineered to code, is the difference between an outdoor space you flee by mid-afternoon and a beautiful, climate-controlled asset you can actually live in. Check the link in the description for a free consultation to get started.